Hello, this is Hui. Welcome to watch my video C++ programming on Linux. In previous video, we demonstrated how to use OpenSSL BIO to read data from source file and write to another file with or without encoding. And the encoding method we used in previous video was base64. In this short video, we are going to discuss OpenSSL EVP interface. OpenSSL EVP is a high-level cryptographic functions. The EVP library provides a high-level interface to cryptographic functions. Using EVP to encrypt or decrypt the message, we can select different algorithms. For example, cipher, AES, DES. We also can select different model. For example, GCM model, CCM model, CBC model, CFE model. The key and IV. IV stands for Initialization Vectors. Here on the Linux, first we create a class called evp_class.h and evp_class.cpp. First, we create a namespace called library OpenSSL. Inside our namespace, we create one class called AES_CBC_256. AES stands for the Advanced Encryption Standard. CBC is a model called Cipher Blockchain Models. In order to perform encryption and decryption, we need to select 4 components: algorithm, model, key, and IV, initialization vectors. In our simple class, we create only basic constructor, destructor, and 3 methods. One called encryption. The method encryption will be encrypt plain text state to the cipher text state. Return the integer is the length of the cipher text state. The second method is decrypt, which decrypt the cipher text to the plain text. Return is the integer is the plain text length. And the third method will be the print cipher text. The input is the cipher text and the length of cipher text, and we print it out in the HTML format. And in our class, we have 2 member variables. One is the key, another is the IV. Here is our implementation. First is the constructor, and for the constructor, we assign the key and IV. In this demo, we just assign the key using hardcode, which is a 256-bit key, 32 byte, and IV is 128-bit, which is 16 byte. So this is a 32 byte string. This is a 16 byte string, which is hard-coded. And our next method is encrypt. Encrypt will be encrypt the plain text to the cipher text. So this is the input, this is output. Return the integer is the length of the cipher text. For EVP encryption, we can select algorithm and models. In this example, we just select AES CBC 256 model. Usually they using the function, so EIV_AES 256_CBC in our method. First, we declare some variable integer length using string length to get the plain text length, the cipher text length, and the return code. In order to encrypt, first we have to create cipher context. The function called EVP_cipher_CTX new. Type is EVP_cipher_CTX pointer, we call the CTX. Second step will be set up cipher context CTX for encryption with the cipher type from the engine implementation. This function has 5 parameters. First is the CTX, and the second is the method or the model algorithm, normally by function. So this is the algorithm model for encryptions. Third one is the implementation. If this one is null, then we use a default implementation. Next one will be the key from our class member. we hard-code it under constructor and also the IV. If there's error, we just print initialization error. Otherwise, we go to the next step. The third step is your EVP encrypt update. This function encrypts any byte from the buffer in and write the encrypted version to out buffers. The function can be called multiple times, encrypt success block updates. This function, first parameter is the CTX, and the second is the ciphertext, which is output, and the third one is the length of ciphertext after encrypt. And next one is the plaintext, is the input, and the length of this plaintext. After this function is a success, we got a length, which is a ciphertext length. In the next function will be the encrypt final. This function will be encrypt the final date. This function will have three parameters. First is CTX, is the context, and the second one is the pointer of the ciphertext plus line and the length after encryption. So the final ciphertext length will equal ciphertext length plus the new length. The next step will be the free cipher context. This will free memory allocated for the CTX objects. The next method will be the decrypt. It's similar as encrypt. The input will be the ciphertext and the ciphertext line, returned plaintext and the plaintext length. Decrypt is similar as encrypt. First, we create a cipher context using the EVP underscore cipher underscore CTX underscore new, and we name it CTX. Second, we're using the decrypt EVP underscore decrypt init to initialize or set up context, and the next function will be the EVP decrypt update. This function will get ciphertext and ciphertext line. Return is the plaintext and the plaintext length. If this function success, we got a plaintext line equal the length. And after that, we do the decrypt final, decrypt any final dates. So the final plaintext length will be this line plus equal the new length. Finished, we just free our CTX and all allocated memories. Next method is print ciphertext. This method gets data from the ciphertext and the ciphertext line as a parameter, and we just use a bio dump fp function to print our ciphertext into stdout. Save this. After finished our class of EVP, first example is going to write a program called EVP underscore display.cpp. In this function, we get a text message from command line and encrypt it using our class, and then we print both plain text message and the ciphertext message, which is the encrypt message. So first, we get the length of plain text equal our plain text message get from argument 1 of command line. We allocated two memory, one memory for the ciphertext, the maximum buffer size defined in our header file of EVP class.h, and the plaintext, which stores our plaintext message. We use mem copy. So we copy our argument from command line to the memory called the plaintext. Next one, we will be print out. We print out source text. Next, we'll initialize our encryption object called enc obj. And we using the encrypt method. First is the plaintext, and the second is the ciphertext. So So if a ciphertext length is greater than 0, it means we successfully encrypted. So we just print out using print our ciphertext. First is the ciphertext, second ciphertext length. Then we finish our program. Now we save our program. We compile our program. So this is our binary. The usage with the date. This is test. Just a test encryption message. So you can see this is our source text. This is the test encryption message, which is from our command line. And this is our encrypted date, which is a binary date, not human readable. Our next example will be write a program to read a text file and encrypt it to encrypted files. And also we read from encrypted file and back to the source files. Our program called EVP underscore file underscore encrypt.cpp and EVP underscore file underscore decrypt.cpp. So the usage will be program name, source file, and encrypted file. So in our program, first we allocate a memory called ciphertext or plaintext. And the size is max buffer size defined in our header files. And we create an in byte, out byte, and the ciphertext length. We initialize a pointer of BIO, one called BIO in, another called BIO out. First, we're going to instantialize our BIO. BIO in equal, and the BIO in from the argument 1, and it's for read. And the BIO out from argument 2, and for write. After instantialize our BIO, we instantialize the encrypt object. And our class is lib OpenSSL AES CBC 256 called ENC OBJ equal. Next, we'll read file, encrypt, write file. So we need a loop. And to read from in BIO is called a BIO read. First is a BIO in. Second, we'll read to, because the source file is the plaintext, so we read into our plaintext memory buffer. And the maximum size will be, this is greater than 0, we stay in the loop. And if not greater than 0, we finish the loop. So next will be encrypt our date, ciphertext line equal. It's an encrypt method. First is the plaintext, which we read from the BIO1, and the output will be the ciphertext. So if our ciphertext length greater than 0, we have to write to our out BIO. Function is called BIO underscore write, and this will be write to out BIO. And from the ciphertext, the length is the ciphertext length. We can verify our write is correct or not correct. So if out byte not equal cipher length, we can break, and we also supposed to write this length, but we will write finish the loop. We close our BIO, so BIO. This is our encryption. And our next program will be the decrypt. For the decrypt, it's similar as encrypt. First, we have a BIO, and we allocate the memory, the ciphertext and plaintext. And we memory set our ciphertext and plaintext. Usage will be the encrypted file and write to the plaintext files. The program is similar as our encrypt. First, we're going to instantialize BIO in from argument 1 for reading and BIO out from argument 2 for writings. We instantialize our object live OpenSSL AES underscore CBC underscore 256. First, we make a loop using BIO read from BIO in. Buffer will be ciphertext and the maximum size of length. And this is the number of bytes we read. After that, we first decrypt using decrypt function from ciphertext. The in byte is the length of this ciphertext. Output is plaintext. Return is plaintext length. If plaintext length greater than 0, we use BIO write our plaintext to the plaintext files. And the length will be the plaintext length after decrypt. If out byte and the plaintext length not equal, we just print out something wrong and then break. Finish the loop, free our BIO in and free our BIO out. Save our program. We compile our program. So now we have compiled. In order to test, we create a test file called test underscore source.txt. Give a test line 1, 2, 3, 4, 5, 6, 9, 0, and 10 lines. First, we encrypt. The source file will be the test underscore source.txt. Output will be encrypted file. Its name is test encoding.dat. You can see how we generate this file. This is a binary file. We convert this. So this is after we encrypted the file. It's not human readable. And our source file is the line 1, 2, 3, 4, 5, 6, 9, and 0. Now we try to decrypt this file. We use EVP underscore file underscore decrypt. In this program, source will be the test underscore encode.dat, which encrypted the file. Output called the test back.txt. So let's get test back.txt. You can see we decrypt our encrypted file back as source files. OpenSSL EVP provides rich functions method of cryptographic functions. It's flexible to select different algorithm, model, key, IV, and make data process more secure. Especially for cloud storage project, it's safer to encrypt your data file and then save onto cloud storage. Hello, this is Hui. Thanks to watch my video. Hopefully this is useful and it's going to be great to have your feedback.